Okay, examples of L'Hopital's rule from entrance exam. Here take the first exam, natural science on 2007. Question number 4. Which one is the following is the limit of x minus 9 over 3 minus square root of x as x approaches to 9? Here, substitute 9 here in the numerator, x minus 9, substitute here 9, 9 minus 9 is 0. Again, here 3 minus under radical x, substitute here 9, square root of 9 is 3, 3 minus 3 is 0, so this one is in determinant form, which is 0 over 0. So using L'Hopital's rule, we can easily find the limits of this one without factorizing the expression factorize ሳናደርግ መስራት እንችላለን. That means what? Let us take the derivative. According to the L'Hopital's rule, we have the limit that as x approaches to 9 of what? X minus 9 over this 3 minus under radical x equal to the limits of this as x approaches to 9 takes the derivative for the numerator and the denominator individually. So the derivative of x minus 9 is, the derivative of x is 1 over 9 is constant, which is 0. Again, the derivative of 3 minus under radical x, here 3 is 0, and negative under radical x, its derivative is 1 over under radical 2 root x. So multiply this one, the reciprocal of that value. So, or easily substitute 1 before that, multiply by the reciprocal. So we have the limit as x approaches to 9 of the reciprocal of this one is minus 2 root x over 1. Then easily we can substitute 9. Here we can substitute easily 9, it is 0 over 0, it is undefined. So indeterminate form. So here substitute 9 minus 2 under radical 9, which means minus 2 under radical 9 is 3. So minus 2 times 3 is negative 6. So this one is what all about. The simplest way to finding 0 over 0 of a given limits without factorizing the numerator with the denominator 1, but it's the limit point, it goes to 0 for both numerators and denominator functions, 0 over 0. So we can use the derivative. This says as a L'Hopital's rule. L'Hopital's rule, it says this one. Other example from entrance exam. Let us see another example. 2009. 2009. We have two examples here. We have seen two examples. The first one here, question number 31. If a is different from 0, then what is the value of the limit as x approaches to a? X square minus 2a square over x raised to 4 minus a raised to 4. So easily to find this one, we can take that, the limit of which one? The limit of this x square minus a square over x raised to 4 minus a raised to 4 as x approaches to a. This a is different from 0. Then substitute a both sides. Here a square minus a square 0. Again here substituting the denominator a raised to 4 minus a raised to 4, it's also 0. So which is 0 over 0. So we can use the L'Hopital's rule here again. So take the derivative for this one with respect to x. So this a is a constant. So its constant is 0. Then derivative of x square, which is 2x over the derivative of x raised to 4 is 4x cubed. This a raised to 4 is a constant, it's also 0. Then as x approaches to what? A. So easily substitute in place of x, a. So that it's equal to 2a over, here we have 4a cubed. Then here by 2, 1, a also 1. Here we have remaining what? 2s by 2, 2a square. 2 by 2, 1. This one is 4 by 2, 2. A cancel out. Here we have 3s, cancel out 1. So a square. That's all about the answer. So easily, without factorizing this one. By the way, in a class, we have using this one factorizing, we can work this and simplify. After that, we can find the value, this 1 over 2a square. 1 over 2a square. So this is the L'Hopital's rule, simplified our works. Especially for entrance exams which is bounded by times. So this L'Hopital's rule more supportable to finding easily or after long factorization. So it's the most easy. In this year, again 2009, we have another question. Question number 32. Let us see again here. What is the limit of that sine x cos 2x over x squared plus 2x? Again, students, substitute here 0, this one, substitute 0 at sin x cos 2x and x squared plus 2x. Both are here 0, 0, 0. Sin 0, 0. Cos 0 is 1, but here we have 0 over 0. So also we can use this one using L'Hopital's rule. It must simplify our results. Let us do that one using L'Hopital's. Okay. Limit of this sin x cos 2x over x squared plus 3x as x approaches to 0 is equal to the limit of the derivative for sin x cos 2x using the product rule. Don't forget, the student, here is the product rule because it is the product of two functions. Okay, so derivate first sin x, then we can use cos 2x. The derivative of sin x, which is cos x, then times cos 2x plus write sin x and take the derivative of cos 2x. The derivative of cos 2x is what? Minus 2 sin x. Here use the chain rule, by the way. Sin 2x. Sin 2x. Use the chain rule. Okay? Then over the derivative for this one, which is 2x plus 3 as x approaches to 0. Let us see the derivatives to simplify or substitute the value. Here you have cos x cos 2x, and here takes the product minus 2 sin x sin 2x. Here minus 2 sin 2x is derivative of cos 2x using chain rule. So that over here we have 2x plus 3 as x approaches to. Here easily substitute 0. So substitute 0 in sin x. We have here what? Cos 0 times cos 2 times 0 minus 2 sin 0 times sin 2 times 0. So sin 0 is 0. Don't forget that one. Here 2 times 0 plus 3. So sin 0 is 0. Cos 0 is 1. 2 times 0 again 0. Cos 0 also 1. So we have 1 over here 2 times 0. 0, 0 plus 3. 3. The answer is 1 over 3. So it is. The answer is 1 over 3. So this one is the way of easily to finding the limits when the determinant is either 0 over 0 or infinitive over infinitive using L'Hopital's rule. Take the derivative of the numerator and the derivative of the denominator. When substitute that point, it makes 0, 0. Again, the other example from entrance exam 2014-15 mathematics for social science, question number 52. Which one of the following is the limit of x over 1 minus under radical x plus 1? Again, here student substitute 0 on the numerator, it also 0. Substitute this 0 again in this radical, so radical of 0 plus 1 is radical 1. So 1 minus 1 is 0. So it is 0 over 0. So it is suitable to using what here? L'Hopital's rule. Let us practice. Okay, to using L'Hopital's rule, we can solve this one again. Okay, the limit of x over 1 minus under radical x plus 1 as x approaches to 0. So substitute 0 both sides, which is 0, 0. So take it's equal to the limit of as x approaches to 0. Take the derivative of the numerator 1. So derivative of x is 1. Again, here the derivative of the denominator 1, which is the derivative of 1 is constant, which is 0. Then the derivative of radical x minus 1 over 2 under radical x plus 1. Students, don't forget, every time we can easily recall the derivative of square root of x, which is 1 over 2 root x. That is 1. Okay, then take this expression, multiply the reciprocal of this denominator. We have limit as x approaches to 0 of the reciprocal for this one minus 2 under radical x plus 1 over 1. So easily substitute 0. So minus 2 under radical 0 plus 1. So that means 0 plus 1 is 1 and radical 1 is 1. So which is negative 2. That is the limit value. Here you have what? At D. So it is a way of using L'Hopital's rule. Students, don't forget the limits of the L'Hopital's rule says that the limits of the function f of x over g of x as x approaches to some x naught. This x naught substitutes in each value of the numerator and the denominator function. It makes both 0, 0, or it makes them infinitive over infinitive. So this equal to the limits of f derivative of x over g derivative of x at x approach to x naught. That is all about for L'Hopital's rule. So that, okay, students, you have question and try your answer for this one. Question number 28. Question number 28. What is the limits of x cubed minus 8 over x squared minus 4 as x approaches to 2? This one is question for entrance exam 2011. Please, using L'Hopital's rule, easily with using 1 minute, we can find the value of the limits of this function easily without any factorization using L'Hopital's rule. Please try this one and write your answer on the comments. Thank you for your listening. To learn mathematics, do mathematics. Don't forget, try this question number 28 and write on the comments your answer, either A, B, C, or D. Please write, subscribe, like, share. The students, this channel, support the channel by giving your answer and sharing this one for the others. Goodbye.